Hello everyone, myself Rakesh K. I am studying Sri Venkateswara College of Engineering. Today we need to study about computer organizations and architecture. Let me study about these sides. The first we have CPU organization and components. In that we have the central processing unit CPU is also known as CPU is the brain of the computer. It is responsible for the executing instructions and performing calculations. The CPU is composed of various components, each with a specific role. And understanding the organization and components of a CPU is essential for the comprehending how a computer functions as it is core. What are the CPU basics are in these slides. The CPU's primary function is to fetch instructions from a memory, decode from them and execute them. These instructions can range from simple arithmetic operations to complex calculations. In that we have a 4 steps, that is ALU means arithmetic logic unit and a control unit. The third is registers and the fourth is cache. The first is ALU. It performs the arithmetic and logical operations on data in the CPU basics, and the control unit manages the flow of instructions and data within the CPU. It's about the control unit. And when we came to registers, it checks the temporary storage locations for data and instructions. And last we have a cache, that is a small and fast memory that stores frequently used data and instructions. That's about CPU basics. And next we have processor and architecture. Processor and architecture refers to the design organizations of the CPU. It encompasses the instruction set and the number of cores and the memory hierarchy. In that we have 3 points, that is non-Neumann architecture and architecture, hardware architecture and RISC and CISC. The first we have to study about the non-Neumann architecture, that is about uses a single address space for both instructions and data. It is called as a non-Neumann architecture. And second point we have hardware architecture. It uses to separate address spaces for the instructions and data enabling simulations access. The third we have RICS and CISC, that is about reduced instruction set computing, uses a small set of simple instructions, while CISC complex instruction set to computing uses a larger set of more complex instructions. This is about the processor architecture. Next we have a instruction set. The instruction set is a collection of commands that the CPU can understand and execute. And the different CPUs have a different instruction sets which can affect the performance and compatibility. The down slide we have an instruction type and a description. There are instruction types are arithmetic, logic and data transfer and control flow. And the description is addition, subtraction and multiplication, division. And when we came to instruction type of a logical, with refers to the description of gates that are AND or not or a XOR gate. When we come to data transfer, the description is about moving data between the registers and memory. Data transfer will be occur from memory and registers. And the control flow, branching, looping functions, branching, looping and function calls. Let us study about memory hierarchy. The memory hierarchy is a system of multiple levels of a memory with a different speeds and sizes. The hierarchy optimizes the performance by storing frequently access data in faster levels. In that we have a 4 step, that is a register, cache, main memory and secondary storage. Main memory is which is also called as a RAM. The registers is which is one of the fastest and smallest memory level, which is directly accessible by the CPU. And we second point we have a cache, faster than main memory, which stores frequently accessed data from main memory. And the main memory, which is known as a RAM, it is a primary storage for the programs and data, which is slower than the cache. And the secondary storage, we have long-term storage for data and slowest and largest memory levels. For example, we have hard drives or SSDs. This is about the secondary storage. The next slide, we have input and output subsystems. In that we have four steps, which is input devices, output devices, controllers and buses. First we need to study about the input and output subsystems. The input and output subsystems handles a communication between the CPU and external devices such as keyboards, monitors and storage drivers. And the input subsystems ensures that data is transferred smoothly between the CPU and the outside world. Input devices, output devices and controllers and buses are the four types. The input devices which provides the data to the computer and like keyboards, mic and scanners. Output devices are the display or output data from the computer such as monitors, printers and speakers. Input controllers are managed to data flow between the CPU and input devices. And for last we have a buses, that is physical pathway for data transfer between the components. It's about the input and output data. Next we have pipeline and parallelism. In that we have pipelining, parallelism and multi-threading. First we need to study about pipelining and parallelism. And pipelining parallelisms are the technique used to improve the CPU performances by breaking down the tasks into smaller units and processing them concurrently. This approach significantly enhance throughout the CPU. First we need to study about the pipelining, that is overlapping the execution of a different instructions to increase efficiency. And parallelism it is used to using in multiple processing units, that is in cores, which is used to execute the instruction concurrently. And multi-threading is one of the running multiple threads of executions on a single core and improving performances and responsibilities. Next slide we have about emerging CPU trends, and it's about the word CPU technique is constantly evolving. Trends like AI, accelerations, quantum computing and neuromorphic computing are the shaping the future of a CPUs and promising even faster and more powerful processors. In that we have AI accelerations, quantum computing and neuromorphic computing. What is the AI acceleration means? It is a specified hardware for the accelerating AI workloads and improving performances in machine learning and deep learning applications. And quantum computing we have 1 minute. And in quantum computing we have exploiting quantum mechanics to solve complex problems that are infeasible for traditional computers. And neuromorphic computing is about mimicking the structure and the functions of a human brain to create energy efficient and adaptable CPUs. It is about the emerging CPU trends. And thank you guys for watching this video. Thank you.